Yeah, combination. A combination is a selection of objects from a group of objects without regard to order. In combination, order does not matter. This means that selecting A and B is the same as selecting B and A. For example, choosing two students, John and Mary, from a class is the same selection whether we write it as John and Mary or Mary and John. Now, the number of combinations of n distinct objects taking R at a time is denoted by n combination R, NCR, or this array n and R in big brackets. And the formula is simply n factorial over R factorial into n minus R factorial. You notice from this formula that n combination R is simply the same as dividing n permutation R by R factorial. Now, example, if we are to evaluate 5 combination 2, it means we are saying n is 5 in this case, R is 2, and so we'll sub them into the formula as n factorial over R factorial into n minus R factorial. That is 5 factorial over 2 factorial into 5 minus 2 factorial. 5 minus 2 factorial is 3 factorial, and so we have 5 factorial over 2 factorial times 3 factorial. If we calculate that, at the numerator we'll have 5 times 4 times 3. We can stop at 3 factorial. Of course, inside 3 factorial we'll have times 2 times 1. That's what I did in the previous video where I stopped at n minus 2 factorial. It's the same concept. And then at the denominator we have 2 factorial, which is 2 times 1, and then 3 factorial. Because we want to cancel out this 3 factorial at the numerator, we'll just cancel out easily now. That's why we stopped 5 factorial at 3 factorial. And so I left with 20 over 2, which is 10. That's our answer. 5 combination 2 is 10. We have a similar example here, 8 combination 3. You can go through that. We have 10 combination 1, another similar example. Let's see this one. If n combination 2 is 15, find n. N combination 2 is n into n minus 1. N combination 2 again is n into n minus 1 into n minus 2 into n minus 3 into n minus 4. We'll keep descending until we get to 1, but we'll stop at n minus 2 factorial, because we will also have n minus 2 factorial at the denominator. Many lines are skipped in this solution, and then 2 factorial as well in the denominator. So the n minus 2 at the numerator, n minus 2 factorial, and n minus 2 factorial at the denominator will cancel out. We'll be left with 2 factorial at the denominator, which is still 2, and n into n minus 1 at the numerator. That's why we have this. And so n into n minus 1 over 2 is 15, as we were told in the question. So we'll solve this. If we take 2 to the other side, it multiplies 15. So we have n into n minus 1 equals 30. If we expand this, we have n squared minus n minus 30 equals 0. And if we factorize, we get n is either 6 or n is minus 5, like in the previous video. And so we'll choose the positive answer, because our n is from the set of positive natural numbers. N cannot be negative. Or whenever we get to this point, n into n minus 1 equals 30. N and n minus 1 are two consecutive numbers, so you can just guess what two consecutive numbers can I multiply by each other to get 30. It's definitely 6 and 5. So 6, the bigger one will be your n, and the smaller one will be your n minus 1. Properties. Take note of these properties. N combination 0 is always 1. N combination 1 is always n. N combination n is always 1. N combination r is the same thing as n combination n minus r. Because choosing r objects is the same as leaving out n minus r objects. Very true. Next, show that 7 combination 2 is equal to 7 combination 5. That's what we just saw here, which this example makes clearer. 7 combination 2 is this 7 factorial over 2 factorial into 7 minus 2 factorial. 7 minus 2 factorial is 5 factorial. If we solve all this, we'll be left with an answer 21. If you do 7 combination 5, same thing, we'll have an answer of 21. Now if you take note, if n is 7 and r is 2, you see that on the other side n is 7 and our base number is 7 minus 2, n minus r, which is 5, and that's why they are equal. So you see we have some applications here. A committee of 4 members is to be selected from 10 students. Since the order of selection does not matter, the number of ways is 10 combination 4. I want to select 4 students to be on a committee out of 10 students. It's simply 10 combination 4. So we can do that in 210 ways. You can make that selection of 4 students out of 10 in 210 distinct ways. That's what we're saying in essence. This next example is also similar. You can read it through by yourself. Remark: we use permutation when order matters, and then we use combination when order does not matter. We have, for example, choosing a president and a secretary from 5 people is a permutation problem because the posts are different. Choosing 2 representatives from 5 people is a combination problem because there are no posts. There are no different posts. Right? I believe that statement is clear enough. We have some more examples. From 6 students, how many ways can a chairman and secretary be chosen? How many ways can just 2 representatives be chosen? So there are 2 questions in there. For chairman and secretary, that's 2 positions out of 6 students. So that will be 6 permutation 2. Right? The order matters in this case. That's 6 factorial over 4 factorial, which is 30. For 2 representatives, how many ways can just 2 representatives be chosen? That is from 6 students. That would be 6 combination 2 this time around, which is 15. I believe we can see the difference. In this first instance, the positions are defined: chairman and secretary out of 6 students. That one is a permutation problem. But when you are selecting blindly, selecting from 6 students to fill up 2 positions, right? The order does not matter in this case because the positions are not defined, right? So you have that. We have another example. In how many ways can 3 mangoes be selected from 7 different mangoes? Since only selection is involved, right? 3 mangoes from 7 mangoes, order does not matter here, so we use combination. 7 combination 3, which is 35. And next, how many committees of 5 people can be formed from 9 people? Order does not matter here as well. The 5 people are arbitrary, they are not defined, and so you can just pick randomly. So in how many ways can we do that random selection? Is 126. That's 9 combination 5. So we have exercises here as well that you can practice. Thank you.